Okay, this part of the video will be over atomic radius. So again, let's look at some data. Here's some data on the basic atomic radius versus atomic number. Okay? Now, here's the first question. When we talk about atomic radius, what are we referring to? If you go back to your model, this is your Lewis dot. We filled in here with this is our nucleus. And there were some things that we said about the nucleus. The nucleus contains your protons and neutrons. Red is probably not a good color for that. So it contains your protons and your neutrons. And your most massive part is your nucleus. So let's make a note here. This is our most massive. And then we have our electrons, and our electrons are out here. I'm just gonna put one together real quick here, not symbolizing anyone specifically, but just for the effect. Okay. So let's just say we have carbon here. All right. So my atomic radius means it is, here is my full scale. My atomic radius is obviously from the center out to my furthest distance, okay? My first electron, which we have a little hard time imagining that you can actually see it and making measurements of it, but we do know a few things. We talked about earlier that the electrons on the inside were shielded by the electrons on the outside, okay? We talked about earlier ionization energy, that if we took these off and we only had one electron out here, then what's going to be true about that one electron there? Well, that one electron is going to want to be removed, okay? And that's when we say that the ionization energy is so easy for it. We can easily pull off that electron. Because this nucleus is very unhappy here. It's got to maintain this second orbital here. It only has one electron. It only has one person that it had to worry about. So that one electron to this atom is not that important. Which is why when we talk about first ionization energy, it's easy to remove that, and then we get a more compact structure. So let's go look at our data. What we're going to notice is, here we go. Look who's on the top here. Recognize these people? Lithium, sodium, potassium, rubidium, cesium, and francium. Remember, they are your alkali metals. And so if we look at the graph here, they have your largest radius. Again, they want to get rid of that electron. That's why they have a high ionization energy. So group 1 is going to be the largest. And as I add on electrons, my electrons here, okay, then an interesting thing starts happening. This atom will start hanging on to its electrons. And so now it's got 4, and it's not going to want to let go of it. And as you add another one, it holds on to it tighter and tighter and tighter and tighter. And so these electrons end up coming towards the nucleus, not ever making contact, but making a smaller radius. Because the nucleus can hang on to all of these 8 wonderful people out there. Okay? So, if we know that this over here is going to be my smaller radius, based on my data that I got over here they are, fluorine, chlorine, bromine, iodine, polonium. Okay, they threw polonium in there, but you can tell, here's your group 7, here's your group 1. We want to add 2 arrows to it, okay? So, when we talk about electron radius, it gets larger as I go down the periodic table. And it gets larger as I go across the periodic table. Make sure you add those to your periodic table, and I will see you next time. Bye.